Period 4, good morning. This is your fifth set for Flip the Classroom. This lesson is for Monday, April 30th, and then I already gave you a heads up of what's going to be. It's going to be finding the domain and range of a function or a graph or an equation. So let's already get started with that. The instructions for all of these 8 examples. Yes, 8. The first one, it is going to be a little bit hefty because we're going to write all the steps down, but then afterwards we're just going to apply the steps for the rest of the 7 examples. The instructions is to graph and then find a domain and range, which I will identify and then define in example number 1. So let's already start with example number 1. It's x minus 3y is equal to 6. This is a linear function, meaning that when we graph this, it's going to be a line. We need to solve for y first, and after that, find the slope, or find the y-intercept, and then graph those. So let's start off with that. We're going to subtract x on both sides. Subtract x on both sides. We have negative 3y is equal to negative x plus 6. And then afterwards, we're going to divide both sides by negative 3, y is equal to negative x plus 6 over negative 3. We can split this up into 2 fractions. This is going to be y is equal to x over 3 minus 2. How did I get that? Negative x divided by negative 3. They both come out to positive, and then 6 divided by negative 3, that's negative 2. We can also rewrite this as y is equal to 1/3 x minus 2. So now we clearly have a y-intercept, which is negative 2. We're going to start from over there. And then our slope is 1/3. Remember, slope means rise over run. And so that means we're going to start at negative 2. And then that means from there, we're going to go up 1 and 3 to the right. So let's graph that over here on the bottom. Actually, try to see if you can fit this all in one page and also the steps. If not, it's fine. You can just fit it wherever you see fit. Okay, but we are going to come back to this graph so that we can find the domain and range of this graph. Okay, we are going to start at negative 2 right over here because this is our y-intercept, and then afterwards the rise and run, we go up 1 and then 3 to the right. 1, 2, 3. Try to see if you have a straight edge. If not, just make it as straight as possible. There we go. So this is the graph for x minus 3y is equal to 6. Okay, domain and range. They're just asking you for all the x acceptable values and all the y acceptable values. So let's already define what domain is, and then I'll give you a procedure on how to find all the acceptable x values. Okay. We're going to come back to this graph. I'm going to use another piece of paper because this is going to be just a little bit hefty for the definitions. Okay, so the domain of function or a graph means the x values that the graph hits. Okay, so the domain of a function means the x values that the graph hits. So after we define a domain and then the steps for this one, we're going to go back to example number 1 for the graph. So how are we going to find the domain of a graph? We are going to apply the vertical line test. Apply the vertical line test. Okay? And then when we do that, please use the x-axis as a guide and look up and down to see if it hits the graph. Use x-axis as a guide and look up and down each time from the x-axis to see if it hits the graph, to see if it hits the graph. Okay, so domain of functions just means all the acceptable x values, meaning the x values that the graph hits. We're going to use the vertical line test right now. So let's go back to example number 1. Alright, we are back into example number 1. So let's use the vertical line test. Remember, vertical line is up and down. So let's start over here. Let's start on this x coordinate over here. Well, if we go up and down, does it hit a graph? Yes, it does. Okay, now let's start with this x value over here. Go up and down, see if it hits the graph. Yes, it does. Okay, Then just keep going over here. Let's use this x value. Does go up and down, see if it hits. Yes, it does. And then if we use this x value, go up and down to see if it's the graph. Yes, it does. So pretty much you can think of a vertical line test as a computer scanning it. So you can go like eh, 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 eh. It seems that we're going to have all acceptable x values, meaning that this graph, remember these two arrows indicate that this line goes on forever. So that means that we're going to have a lot of x values, and we're pretty much going to have infinite amount of x values if we're going to use the vertical line test, because it's just going to go on forever. So the domain for this is all real numbers. Okay, x is equal to all real numbers, meaning that when we use the vertical line test, it hits on every x. When we look up and down, yes, it hits the graph. When we look up and down, yes, it hits the graph. Okay, and these lines, remember, these lines indicate, sorry, these arrows indicate that this line goes on forever. Okay, so that's a domain of this function, or this graph. X is all real numbers. All real numbers, this is a little bit different from what you're used to. I think sometimes you wrote it out for Algebra 1. For Algebra 2 and from here on, it's just an R, but you just make a double vertical slash on that first stroke. Okay. All right. Let's do the range now. So if the domain of the function means the x values that the graph hits, range is just the y values that the graph hits. Okay. So range. Let's put this up over here. Range of a function means the y values this time that the graph hits. And then instead of applying the vertical line test, we are going to use the horizontal line test and use the y-axis this time as a guide to see if it hits the graph. Okay, apply the horizontal line test, and then we are going to use the y-axis as a guide and this time, since we're using the y-axis, every time we do the horizontal line test, we're going to look left to right to see if it hits the graph. Okay. All right. Let's go back to example number 1. So this is all pretty much the big meat of the notes, and then after that the rest of the 7 examples we are just going to fly by and find the domain and range. So let's go back to example number 1. The domain again for x is all real numbers. Let's do the range this time, and then this time we are going to do the horizontal line test. Okay, so I guess we could start over here, and then we can start over here. Look at your y-axis. Look left to right to see if it hits. Bam! Yes, it does. And keep moving up. Okay, let's start over here. Let's see if it hits the graph. Yes, it does again. Okay, we keep going up over here. Okay, let's see if it hits the graph. Yes, it does again. Okay, remember these arrows indicate that this graph pretty much goes on forever in both directions. So all your acceptable y values, it's going to hit all your y values anyway. So this is also all real numbers as well. Okay, all acceptable y values, all acceptable x values. So all y values, and then we can even put in over here as a side note all x values as well. All x values. So that is a domain, and this is the range of this function. Okay, domain, all x values hits. The range, all the y values, it hits on this graph. Okay, so again, domain. We're going to apply the vertical line test and use the x-axis as a guide, and then for range we're finding the y values, so we're going to do the horizontal line test and use the y-axis as a guide for this. All right, let's do the rest of the 7 examples. We're going to graph first and then find the domain and range. Our next graph is y is equal to negative parentheses x minus 1 close parentheses cube plus 1. So like I said before doing this video, see if you can also recollect your memories, recollect your notes about the parent graphs, because we're pretty much going to do all of them again one more time. Well, our starting point is going to be at 1, 1. Okay, and then just as a little reminder, whatever you see in the inside, it just needs to be the opposite of what you see. The opposite of negative 1 is 1, and then after that, the k value for the starting point is just as is. Okay, so let's already graph that over here, starting with 1, 1. Okay, let's start at 1, 1 right over here. The parent graph that we are going to mimic is the y is equal to negative x cubed, and for that pattern we're going to go 1 to the right, 1 down, and then after that we're going to go 2 to the right and then 8 down. So 1 2 1 2 3 4 5 6 7 8, and then that means that we're going to go the opposite way. We're going to go 1 to the left, 1 up, and then 2 to the left, 8 up, 1 2 1 2 3 4 5 6 7 8. So try to be as exact as you can, and then connect the dots like so, and make sure you curve it as best as you can, like this. Okay, step 1 is done. Step 2, let's find the domain of this graph here. Remember, for the domain, we're going to use the vertical line test to see if it hits whatever x values it hits. Okay, well, it's pretty obvious that it does hit over here. Remember that these arrows over here indicate that this graph pretty much goes on forever in this direction and this direction over here. So even though it doesn't look like it, it will hit all x values eventually. It will just take a longer time to do so, because this arrow will just keep going up and up and up and up and up. Eventually it will hit all the x values. It just will just take a longer time. The same way goes for the other side as well too. It will hit all these x values if we just extend this line forever, which we will not do, of course. Okay, so the domain is going to be all real numbers for x. Okay, it's all real numbers for x. Range, remember, we're trying to find all acceptable y values, so we're going to use the horizontal line test this time. So let's do that. Okay, look at your y-axis, look left to right. Yep, it hits. Over here, let's look at your y-axis, and then if it hits left to right, yes it does, and then yes it does as well. Remember, again, these arrows indicate that these go on forever, and it's going to go on forever also in the y direction as well. So the range for this is all real numbers for y, and this is example number 2.